Okay, let's start today. Oops, let me turn on some screens, maybe. Hey, um, so it's Monday, so we're going to start looking at a new unit, unit five. And this is where we're getting into what we call loops here. There are th three main structures in computer programming. One is just sequential, and we kind of start with that, where you go statement after statement. You start at the first statement, you do that, the computer does that, goes to the second statement, does that, go to the third statement, does that, go to the fourth statement, does that. It just sequentially processes. And that's kind of the default computer operation. And again, that's kind of the same way you work too. If I, give you a list of instructions, you generally start at the top, do the first instruction, do the second instruction, do the third instruction. If you ever follow like a recipe, I've been baking over something like that, I do the first instruction on the recipe, go to the second instruction, etc. Um, then we learned if thens, and those are these kind of selections. So you can say, if this is true, go down this, and otherwise do that. And that kind of introduces this whole branching stuff where we can keep going through, and at some point we can branch and do some statements and then come back and then continue. So, or else, have a branch where you go this way or this way, do some statements and come back. So branching is with our if thens stuff. The last thing, the third part we need to do is looping, where you'll do some statements and then you'll loop back up and do those statements again, and loop back up and do those statements again, to repeat things over and over again, or as many times as you want there. And so that's what we're going to get into this week is these loops. And there's two kinds of loops, what is called a do loop and a do while loop here. So we'll start working with those. Um, So today we're basically just going to go over the learning material um, and work through a bunch of samples for the learning material. I'm going to close this door a little bit so don't pop over too much. So let's look at do loops. Um, they're covered, again, loops are so critical. They're covered in all three textbooks. There's a separate section in each one. I think I'm going to jump into the Think Java first and look at that one. So I'm going to jump into the second one, the while loop 6.1 in Think Java here. Okay, here's our simple loop. We set n equal to 3 and say while n is greater than 0, we we start a loop brace that goes down here. And inside that loop, we're going to print out n and say n equals n minus 1. And then when we're done, we're going to say blast off. So this is our loop. Now, this is one of these places where I really think it helps to try out this code in NetBeans. So I'm going to open up NetBeans and try it. And I suggest you try out the code. You certainly don't have to. We're not turning anything in today. So you can just watch if you want to. But I'm going to try out this code. So, and we're going to try out a bunch of codes. I'm just going to make a generic project. And, and this is going to be unit 5 loop samples, where we'll try out some different loops. And I'm just going to take this code. And again, this comes from the second one, 6.1, the while statement in Think Java. Here, I'm just going to take that code and paste that into my main application where it says to do put code here. Here. I'm going to just go to source and format to get the indenting formatted. Let's just delete some of these comments again to clean things up a little bit. Zoom in a little bit more. So let's try this code. So what do you think this code is going to do here if we run it? So we're just going to run the code, and it's going to go 3, 2, 1, blast off. So one of the things that the textbooks will talk about is now it helps to start kind of following along with the code and seeing if you can figure out what the code is going to be doing. I'm just going to open up a notepad here. It's I don't just regular notepad, I think. So I can just take some notes as I'm working on this. So let's see. So I'm going to keep track of my variables and as I'm walking through the loop. So the one thing I have to keep track of is n, and n equals 3 to start with. So I'm going to keep track of n, and it's going to be equal to 3 to start with. Let me just increase that. Okay. So I got n equals 3 here, and then I might start my next. And again, I by default I just go line by line here until I get to a loop. So I did this first line. I'm going to the second line while n is greater than 0. Is that true? That's a true or false statement. N is 3. 3 is greater than 0, so that's true. So since it's true, we start our loop. We go in our bracket here. So then we'll print out. So maybe I'll keep track of, well, I can just see my output down below. So I'm going to print out 3 down below. It's going to print out n, which is 3 here. Then I get to this statement, n equals n minus 1. So n is 3, minus 1 is 2, and I'm going to save that in n. So that makes n now 2. And now I hit this brace of the while loop. And what that means is I go back up here and check if this condition is true or not. If it's true, I go through the loop again. If not, I just stop the loop and keep going. So I have to decide at this point, do I loop back up, or do I go to the next, do I print off the blast off here? So I have to check if this is true or not. Is n is 2 greater than 0? That's true. So that means I loop back up and continue the loop. So while this is true, I'm going through this loop. So now I'm going to print off n, print line n. And so that's going to print off 2. So now I printed off 2. And then n equals n minus 1. So n was 2 minus 1 is 1. So now, and I store that back in n. So n is now 1. So every time through, I decrement n. I subtract 1 from n. So now I go back up here. Is n greater than 0? 1. 1 is greater than 0, so that's still true. So while it's true, I keep going. I'm going to print off. I'm going to print off 1. And again, I'm going to subtract 1 from n. So n will be 0 now. And this comes to my crucial time. So now is 0 greater than 0? So no, it's just greater. It's not greater than or equal to. It's just greater than. So is 0 greater than 0? If n is 0, then so that's false. So now this is false. So as soon as that's false, I don't loop anymore. I don't loop back up. So now I'll just print off blast off. So I'll print off blast off here for this. So again, it's going to just keep looping here until n gets to 0. So I could change this. What if I change this? I start at n equals 10. What's it going to print off now? If I change n equals 10 and do this, what's it going to print off? So I run this. It's going to say 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Okay, it's going to keep looping until I get to blast off, until it gets to n equals 0, when it is going to subtract 1 from n each time through the loop. So I'm going to set n equal to 10. I'm going to print off 10, decrement n, so it'll be 9. 9 is still greater than 0, print it off, decrement 8. 8 is still greater than 0, print it off, decrement 7. Um, 7 is still, 6, 5, 4, 3, 1. 1 is still greater than 0. Print off 1, 0, and then I stop this loop here. So again, this is a thing, or I think it's helpful to get, have this code and try things out. Like, what happens if I said n greater than or equal to 0? What's that gonna print off if I say that? So now I'm saying if n is 10, and while n is greater than or equal to 0, print off n and subtract 1. So how is that going to change anything? So now when I run it, it says 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. This time it does print off 0 because I said greater than. So when it's 0, 0 is still greater than or equal to 0. That's true. So it goes through that loop one more time. But now then n gets to be -1, and -1 is not greater than or equal to 0. So it stops there. And if I go back to just greater than, it'll stop at 1. What if I put 100 in here? What's it going to print off? So it's going to count down from 100, 50s, 40s, 10s, all the way down to 1, and then say blast off. What if I say 1,000? What if I say 10,000 there? What's it going to do? Actually, it takes a little while to do 10,000. So 10,000, 8,000, 7,000, 6,000, 5,000, 4,000, 3,000, 2,000, 1,000. Okay, 700s, 500s, 500s, 400s, 300s, 200s, 100s, 80s. Got to get that. Okay, finally it gets to 1. So it actually displays all the numbers from 10,000 down to 1 there. Okay, I'm going to go back to 10. Here's a question. What if I say, let's say, what if I instead of saying n equals n minus 1, what if I say n equals n minus 2 every time? So every time I take 2 away, what's it going to print off then? So it's going to go 10, 8, 6. So every time it's going to take 10 minus 2 is 8, minus 2 is 6, 4, 2, blast off. There. What if I do 10 minus 5? I'm going to start this at maybe at 100 this time. So if I start at 100 and go by 5s, it goes 95, 90, 85. So each time I'm going through this loop, I'm subtracting 5 from it until I get down to sometime when it's less than 0, or as long as it's more than 0, I keep doing this. What if I if I started at like 11 and did this, it's going to do 11 minus 5 is 6, minus 5 is 1, and minus 5 will be -4, so it'll stop there. What if I'm going to go back to 1, minus 1. So if I do minus 1, it's just our countdown, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What if I do plus? What if I want to count up? What's that going to do there? So each time I'm going to start at 10, I'm going to print it out, I'm going to add 1 to it and loop around, add 1 to it, print it out, add 1 to it, print it out. When's it going to stop? it's, it's not going to stop. So let's just keep going around, just keeps counting. It's a very fast counter here. So eventually, that's why they have a little stop button here. So this is what's called an infinite loop. It'll just keep counting and counting and counting there. So let's run this again. Will this ever stop? Um, it actually might because where in math we have as many integers as we want. In computers, we don't. We run out of integers. We run out of numbers at some point there. So it's kind of like uh, we used to have these cars with not digital, with analog odometers. You'd turn them over, and then they'd only have 99,999. So at some point, it was a big deal when your car turned over 100,000. It went from 99999 back to zero, and it all was zeros again there. And so every time, so there's some counters where as you keep counting, 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 when you get to the top, the highest one, it goes back to the beginning there. And with integers, when it gets to the biggest integer, it'll wrap back around to a negative integer. And at that point, it would be less than one. But there's a lot of integers. So we have to count for quite a long time there. So if we actually, this is not, I mean, I'm still not even, we're only at 2 million there. So, um, but it might stop. So now, how would I change? What if I wanted to count from zero, from 1 to 100 here? What would I want to do? I'd want to change, try to get it so the ends. Okay, so I change it so that maybe I'd start at n equals not 10, but let's say n equals 1. I'd print that off and add 1 to it. And I want to keep doing it in it while maybe while n is, what do I want to do? Maybe if I want to count to 100 while n is less than 100 here. So count, let's just do 10. Count from 1 to 10. So again, I could switch this around. So now I'm counting up here. So now it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, blast off there. So again, I can, if I'm incrementing it every time, adding 1 to n every time, I could start at 1. And again, I just have to work with my comparison here, whatever my logical statement. While n is less than 10, do that. And again, I could count to 100 that way. I could, if I want to. So if I want to start and count to maybe 100 by fives, I could do something like this. And it's going to go 1, 6, 11, 16 because I start at 1. But maybe I should start at 0 then. Or maybe I'll start at 5. Then I'll start at 5, 10, 15, 20, and I'll go up to 100 or go up to 95. If I want to go to 100, I can do that. And I should go from 5 to 100. So again, this is a loop and it's good. It's nice to have a loop like this. And I think it's fun you should sit down sometime and think of things and try to change a simple loop like this and see if you can get it to work the way you want. Okay, so let's look at a couple. So again, this is idea, a loop. We check our condition if it's true or false. If it's true, we do the statements there. If it's false, we stop doing it. So is it always going to print off a number? What if we say while n is, let's make this less than 100. So let's say we started at 200 here. And we say, well, n is less than 100. Is it going to ever print anything off here? So it'll never do anything in the loop. We'll never print off a number. It will just say blast off. So again, in this type of loop, we check our condition. Only if the condition is true do we do the statement. So we check our condition first here. But again, here's our infinite loop. Here we set n equals 3. We say, well, n is greater than 0, print n, and we never change n. So that'll just loop forever here. So now there are some statements here. Let's grab this one. I'm going to format that. I'm also going to then comment this one out for now. Okay, so, oops, I need n. I'm going to move that down here. Okay, I'm going to set n equal to 2 to start with. Okay, so while n does not equal 1, we print it off, and then we check if it's even. We divide by 2 and see if there's a remainder. And if it's even, we divide it. Because it's an even integer, we can divide by 2. Otherwise, we take 3 times n and add 1 to it. And we keep doing this. And again, this one's quick. 2, we divide by 2 is 1 there. What if I try 27 here? What'll that give us? So 27 here. 27 is not even, so we take it times 3 and add 1 to it, and we get 82. That is even. We get divided in half. That's 41. That's not even. We multiply it by 3 and add 1. We get 124. We keep going, and we get some really bigger numbers here, and go back down to small. Do we ever get to 1 there? So here, we finally get down to 1. Or to 2, and then that'll give us 1. I should print out n once at the end, maybe, but so at the end it gets it to 1. So again, it went quite a while here, but some numbers might not. So if I try n equals 13, how long will that go? So that doesn't go long at all. So it's hard to know. One thing we often ask, will these loops quit? Because we don't want infinite loops like this one. So we call that the halting problem. Can we determine if this loop will halt there? And this equation, or this set of equations, we don't actually know no one's been able to prove if this will halt for all numbers here. Because there are big numbers you'll put in here, and it's pretty easy. So if I say like 10, 24, that's going to halt, keeps dividing by 2. But if I do 10, 25, that goes for longer there. So again, we don't really know if this will halt. So sometimes it's a problem with these loops to tell if they halt or not. I'm going to show you one more. I'm going to go back. Let's comment this back up and uncomment this now. Let's go back to the original. We started at 10. We wanted to say, while we're greater than 0, we're going to say n equals n minus 1. To do our countdown. Now, there are lots of ways to do increments and decrements here. So this is 1, n equals n minus 1. We see that so much we have a shorthand for that. We can say n equals minus 1. And that's the same as saying n equals n minus 1. So this does the same thing here. No, I did that wrong. Minus equals 1. N equals minus 1 is so n minus equals 1 does this. There's also, we can say just n minus minus is another way of saying that. And that'll do the same thing. Same thing if we're counting upwards. If we want to go from 0 and do this while n is less than or equal to 10, we can say n equals n plus 1. So it'll count from 0 to 10. But we can also say n plus equals 1. And that'll do the same thing. Because this decrement is so common, we can do it there. That does the same thing. And again, same with n plus plus. That'll do the same thing. So there's a number of shorthands for doing this. And some of the textbooks skip over it, but this actually talks about these increments and decrements here. Again, if we want to count by fives, n plus one plus always does one, but if we do n plus equals five, that'll add five to it each time. That'll go 5, 10, 15, whatever. So, and then next week, when we get into the for statement, we'll use those shortcuts more often. So I just want to mention them now. Questions on these for statements? I mean, these while statements? Let's see if we see about the same thing in the other textbooks. Intro to programming. Again, we say while and some Boolean expression, and then we have our statements after it there. So while this is true, we do those statements. And it walks through some pseudocode here. Let's say we want to have an average, a set of numbers, positive numbers the user enters. So we want to say, start with some variables, the sum and the count of the numbers. And then while there are more integers to process, we're going to read in the integer, we're going to add it to the sum, and then we're going to count it. And when we're done entering in all the numbers, we're going to take the sum divided by the count to get the average and print that out. There's two real types of loops. We have only looked at one, the while loop here, and so this sets up this. There's also a do while loop here. This talks about, do you want to check your condition before or after you do this loop through it? And then here's the actual code for this. I'm going to just copy. I'm not going to copy again. I like to just copy the main part of this. Here, so I'm just going to copy this and put this in here. And I'm just going to comment out all of this code. Okay. This textbook doesn't use a scanner here. So when I bring this code over, it doesn't quite work. So I have to kind of change this when I get an input number. So I'm going to replace that with how we do it with a scanner here. So I'm going to say, well, first I'm going to have to declare a scanner. And do that import. And then I can say scanner, my input dot next int to get that. And again, there are a couple other places where I'll need to do that here. There. Okay. So now I can run this. It says enter your first positive integer. I'm going to enter 5. Enter the next positive integer 0 to n. So I'm going to say 3. And then I'm going to go 7. And I'm going to hit 0 now. So it should find the average of 5, 3, and 7 there. So that's 15 divided by 3 is 5. So it says the average event of 3 positive integers, the average of is 5. So that's what it's doing. And again, I can enter as many integers as I want. I could enter just 2, 5, and 6, and then enter 0. And it'll tell me the average. I've entered 2 integers, and the average is 5.5. I can enter a dozen integers here. Big ones, little ones. Enter about, and finally enter 0. It'll tell me I entered 9 integers and what the average is. So how does it do that here? So we initialize our sum to 0 and our count to 0, and we ask this. Now, In this one, we've got to we're going to enter the first integer right away before we get to the loop, because we need that first integer. So we're going to ask them to enter the first integer, and then we're going to check if that integer is zero or not. And if not, I mean, if it's not zero, we're going to start doing our loop, and we're going to keep doing our loop as long as they don't enter a zero. So now once we have that number, we add it to the sum, add it to the count, print off, enter the next one, and read in the next input number here. So we're going to do this as long as they keep entering numbers that aren't zero. Eventually, they'll enter zero, and we'll go down here and print off the results here. Now, they may have not entered any numbers, so if they don't enter a number, we just tell them that here. But this is how we run. So this is a little more complicated example. We call this input-driven stuff here because we keep looping depending on the user's input for this. Now, there's another statement. This is what we call a while loop. There's another way of setting this up with a do while, where the while's at the end here. And this loop would work out fine with a do while also. And do whiles are good because it always does what's in the code once. So here we always want to have them enter at least one number. And if you always want to enter at least one number, that's probably better for, we can do it as a while loop, but we have some input here and input here. We do it as a do loop. We just kind of switch this around. We'd say do, and then move the while down here, and move this, our pass condition here. And then we would enter, well, we just kind of, this we could, we wouldn't do it up here. We'd just say do loop. We'd say enter an integer. We'd read that in there. We'd add it to our sum, and we'd add it to our count here. And we'd do this while our input number is less than or equal to zero here. Oops, I forgot. I deleted my scanner. Need that. Okay. So this would do basically the same thing. Read in our numbers here with a do loop. So again, there's a do, and then we check for a while at the bottom. And then there's a while, and then we check if we're going to start the loop at the top. And we'll talk more about these examples later. So there's these a while statement and a do while statement for this. So they're showing this. This is our do while, and this is a while here. So again, if we're going to do something, we can say do and then do that, and then while some expression. Or we can say while in that expression, and then we can do something. But sometimes we have to replace it or not, depending on how, and sometimes we might need an if then to kind of set this up. So there'll be some places where the while loop will work better than the do while loop, and some places where the do while loop will work better than the while loop. So we'll have to kind of learn that this week. Now this book also talks about the break and the continue statement. You are generally not allowed to use the break and the continue statement, so we're not going to cover them. So there's some expert programmers, and again, if you get more advanced programming, you do use break and continue sometimes. That'll break you out of the loop or just continue just doing the loop, but we're not going to cover them in this class, just so you know. Okay. I'm going to go to the CS Awesome stuff now and look at that. So again, they're kind of comparing the if with a while. So an if, we check some condition and we have some statements. While, we have some condition, we have some statements. How are these different? The if will do the statements once if the condition is true. The while will keep doing these statements while that condition is true. So we keep looping through this while the condition is true. The if only does it once and then keeps going. So that's why they kind of look the same, but the while is a loop and the if is kind of a branch and keeps going. So, if you remember App Inventor, we display it like that in App Inventor for that. And again, they're showing this sort of idea. We check our condition. And if a condition is false, we exit the loop and go to the next statement. If the condition is true, we do whatever's in our loop, and then we go loop back up and check our condition again. If it's true, we do the loop and loop back up. And that's why we call it a loop, is you're literally like walking in circles here, all around and around, doing the same thing over and over again there until some condition is false, and then you'll leave for that. So there's 3 common steps for setting up a loop. We usually do some initialization. So like here we say count equals 0. We do some test while count is less than 10. And then we do the loop, and then we change the loop variable or whatever our condition in here. So this might be asking the user for new input if we're testing that out here, or we're incrementing here. And again, you can see this loop. What is this loop going to do? So can you predict the output of a loop like that here? And again, sometimes that's nice to actually just go over here and type in that loop. Here, I'm going to comment all that out again and try. Int count equals 1 while count is less than or equal to 10. System out print line count plus plus. That's just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to print off 10 here. For this, it's going to start at 1, print off 10 for this. Count plus plus adds 1 to count. Again, we could have just as well, like before, we were saying count equals count plus 1. That would do the same thing here. We were just mentioning the do while loop. Let's look at that real quick here. I can say do, and then I can move the while down here. And then my Boolean expression has to go down there with the while. Now, the do while is is kind of a strange statement. I do need a semicolon at the end. Usually, if I have a while up here, I don't need a semicolon because it's not the end of a statement. But here, do while, this is the end of a statement. So I do need a semicolon there. So again, what does this print off? Basically, it does the same thing. It said count equal to 1, prints it out, prints off the count, adds 1, goes, and then while count is less than 10, goes through, does this, prints it off, adds 1, prints it off, increments count, checks, prints it off, increments count, and it keeps doing this as long as count is less than or equal to 10. When it gets to 11, it's going to not loop up and print it out again for this. So again, this is just another way of structuring this loop with you can say have the while at the beginning, or you can say do and then stick the while at the test condition at the end. This sort of stuff, it'll always do the statement at least once. So it's always going to print off count at least once here because it always does the loop and then checks the condition. So here you can actually run this here in their stuff. So I can run this, do the same thing here. There. So the ears actually open, and they want to change. They want you to change this so that it change it so it counts from 10 to 2 to 10, and has you try that. So that's a good exercise. See if you can change this code so that the expected output is this and not this. Can you get it to match that? How would you change this loop to do that? Would you need to change this or this or this or that? And they walk through tracing loops. They like to use a table and walk through, like I was showing you earlier. Just I sometimes just have a piece of paper and I write down my variables on a piece of paper and keep track of them as I go through the loop and cross them out or whatever, erase them and write in new values. So a lot of times it is helpful to be able to kind of walk through or trace loop activities here. So you kind of get an understanding of how this works. This is nice. There's a lot of good practice loops in here that I think are good. So again, this one, if x equals -5, and while x is greater or while x is less than 0, we're going to add to x and print it off. So what is this going to print out here? Is it going to print out? So the first x is -5. Is it going to print off this one? So, well, should I select that one? So that one's going to be wrong because I set x to -5, but right away I add to that. So that'll make x -4. So by the time I get to the printout statement, it's going to print off -4 here. So this is actually the correct number. Uh, so, and again, they walk through this infinite loop idea here, and they have some more coding exercises. They talk about an input controlled loop here. We'll look at some of those. I don't love this example, the magpie example that well. I think it's a little bit too complicated. So we'll look at some future ones there. But this is what we're going to be doing in class here in just a sec, is this guessing game. Pick a number between 0 and 100, and you're supposed to guess what it is and say too high or too low, and we're going to code that here. So here's their kind of pseudocode. We're going to choose a random number between 0 and 100. We're going to ask the user to guess the number. We're going to read that in. Then we're going to loop, and if the guess is too low, we're going to print off too low. If the guess is greater than the random number, we're going to say too high. And we're going to get a new guess, and we're going to keep looping until they get the number right. And then we're kind of going to finally print off, you got it here. So we'll do that in just a sec. That is down here, our high-low guessing example. So we'll wait a sec to do that. There's a couple of videos that Chris has recorded to look through these loops here. He works through this math example one. I'm just going to open this up in GitHub so we can see this. Oh, it was last week we looked at this math example here. We display this menu. We're adding, you can choose to either add 100, subtract 50 or whatever. You can display this menu here, and we'll read in their choice here. And now we're going to actually start a loop here. We're going to say while choice does not equal quit, while they haven't chosen number 5 here, we're going to go through, and this is our loop, and this is our switch statement. We can do these things here for this, and we're going to loop over again and again through this stuff here. And then we're going to display our menu again for this. Now this is using what we call the while loop. We can also do this with the do while loop here. And we say do, we display our menu based on the choice, and then we say while choice does not equal quit here. I'm actually going to just take this. I'm going to create, this time I'm going to create a new example. Unit 5, math, loop, or loop. I'm going to take this and put it in our code over there. I think it's kind of interesting just to see how this is working here. Um, okay, so if I run this, it displays, oh, what number would you like to start with? So I'm going to start with the number 55 and says, what do you want to do? You want to add 100, subtract 50? I'm going to subtract 50. I'm going to hit 2 as I, or subtracting 50. And now what do you want to do? Here, I'm going to add 100 to it. I'm going to add 100 again. And so each time it'll show me my current number is 2 or 5. I'm going to divide it by 3. That's the fourth choice here. And eventually, I'm going to hit 5. I'm going to quit, and it's going to stop. So it'll keep displaying this menu and for me, displaying this menu until I hit 5 to quit. And again, right away, I say I'm going to start with the number. And if I just say I want to quit right away, enter 5, it just quits here. So it just keeps looping around. And so that's what this does. Uh, we do some setup, ask for the initial number in our calculator, and then we start a loop. We display our menu. Based on their choice, you do something, and we keep doing this while their choice is not equal to quit. And quit is actually defined as a constant up here, which is 5, because basically, as soon as they enter 5, we want to quit. So rather than saying, well, choice does not equal 5, we just have it as a constant in this example. So Chris, if you want, Chris walks through this example in more detail. Here's 2 pictures of it here, but he walks through this. Here's a good way of kind of to see when you might want to use the do while loop. So we always want to display the menu, ask the users their choice, and do a switch statement. And so it works well with the do while loop. This is the do, and then our while checks our condition at the end. Do, we display the menu, get the reader's choice, have a switch statement, and then while I haven't done quit, we can loop back up and do this whole thing again. And then finally, we display the number. We can do the same thing with a while loop, but it's actually a little harder. We have to we always read in we display the menu and read in the choice. And once we have the reader's choice, then we do our while statement. And if it's false, we skip. If it's true, we do our switch statement, display the menu, get another input, and then loop back up here and loop back up for this. So in one place, we have to have the menu and the reader's choice 2 places. Here, we just have to have it once, just the way the structure of this loop. We always want to display it at least once. So Chris talks about that in these videos some more. So it might be worthwhile to listen to those videos outside of class. How are we doing on time here? I'm going to skip over this math library stuff and we'll get to that a little bit on Wednesday. I want to get to this loop example. So what I'd like you to do is, again, where am I at? I'm in the Unit 5, the learning resources. I'd like you to try this example. Scroll all the way down to to this loop example. And there's the guessing game starting code here. So I'm going to start a new project in NetBeans. Called guessing game. Then I'm going to take the code. I'm just going to take the main part of the code and paste it in here. in my over my main here. And I also have to import the random and the Java util. I could also just grab it. That's these two imports. I could grab those imports and put them right after my package declaration up here. Now I can run this code. It says, welcome to object of the game. Guess what number I'm thinking of. Pick a number between 1 and 100. What's your guess? I'm going to guess 24. And it says too low, and that's it. Not a very exciting game. Not that this is ever really that exciting a game, but we want to make it a little more exciting. There. So your job is to add a loop, add a do or a while loop here, so that we get the user's guess, and as long as the user hasn't got it correct, we keep looping around. So we want to do this part. Again, we pick out the secret number. We just have to do that once there. And then we're going to do this part again and again. So can you figure out how to put a loop around that section there? And what condition do you want to check for that? And remember, there's two kinds of loops, a while loop and a do loop. So do you want to check your condition, your while condition at the start of the loop or at the end of the loop? So try to look at that. We got about 10 minutes to figure that out. Again, I want to be looping through this, and I actually think a do while loop works better here, but I'm going to start trying a while loop here. So I'm going to say while and then start my loop. And I'm going to move the bottom of my loop down here. I'm going to update my format so it has indenting right. See the end of a while. But within a while loop, I have to check some condition there. So I want to keep looping. So if I play this game and I ask you to pick a number, and I have a secret number, and I say, can you guess it? And then you say some number. I say too high, too low, too high, whatever. When do I stop? I stop when you get the number right, when your guess is my secret number. So as long I want to keep looping while your guess is not my secret number here. So I'm going to say while we have a secret number variable, while the secret number does not equal their guess. One of the problems is I don't have their guess yet. It's down here after my while statement. So maybe I don't want to do that there. I'm going to move that up here. So I'm going to get their guess. I'm going to pick the secret number, get their guess, and they say while the secret number does not equal the user's guess, I'm going to start looping my loop through and tell them it's too long or too short. Now that's not quite right. If I run this, okay, what's your guess? I'm going to pick 37, and it's going to tell me I'm too high. It's going to keep telling me I'm too high again and again. It's going to tell me thousands of times I'm too high. there. So I'm not doing something right there. So I'm asking them for their guess, and then I'm starting my loop, but I never ask them for another guess here. And so it just keeps saying that one guess. So that's not, so I've got my while loop here, and this is inside the loop. So see if you can figure out this isn't quite right. Why isn't this right? Or can you do it? Can you figure out a way to do this so that I keep looping until their guess is right and let them guess multiple times? When we run it, we want to say, pick excuse me, a secret number and have them do a guess. So they'll do a guess and it's too high. And then you ask for another guess. So I guess something lower. That's too high. So I guess a lower number. That's too high. Well, it's a low number. 6. That's too low. 8. Too low. 10. Too high. 9. Got right. And stops there. I should tell them eventually they got it right, maybe, um, for this. Um, so again, right, I did a while the secret number is not equal to the user's guess. In order to do the while, I had to ask them for their first number, then start the while, and then check if it's right, and then get the number again. This would actually be better if I did a do, and then move this while down at the bottom. Because then I can do the user's guess only once. I don't need it here. Let me get my formatting correct. So now I can get the user's guess, display something, and keep doing it while the user's guess is not here. In order for this to work, I have to actually declare my user guess variable, and we'll talk about this next class a little bit outside here. We have to talk about scope of variables here uh, and do something like this. Now it should tell me, what's your guess? I can guess a number and keep guessing. And it should finally tell me you got it for that. So we'll revisit this on Wednesday. So there's versions of this code here with a while loop and a do while loop. If you want to see, it should be basically the same code I have here. So and we'll work through the learning exercise on Wednesday. Oh, we have community day. Maybe that, yeah. So never mind. You're hopefully doing some fun volunteering on Wednesday, not this. So Friday we'll do that. Yeah. So all right. Yeah.